Hello, my name is Edwin Valladares, and I'm Professor V. And today we're going to be talking about interpreting graphical data. So, as we look at the graphical data aspect of things, a lot of people get a little bit intimidated because of what they see. They see numbers, and it can be intimidating. But what we're going to do is we're going to break it down today in what are the best ways to tackle something like this. Okay. So, first of all, we're going to look at what you have to ask yourself. And what you have to ask yourself is what kind of graph is it? So, we're going to go into a couple of basic graphs. And what is the graph trying to explain? You have to understand what the purpose is so you can start to understand where the data is going. And is there enough data or does the data have enough power? Okay. What I mean by power is there enough representation in the numbers? If there's not enough representation, it could just be a smaller subset, a smaller representation. That's more of a statistical question or definition, which we're not going to get into this class, but I just wanted to touch on it a little bit. Okay, so in order to start, let's look at the type of graphs. Okay, note that there are some different examples. We're going to look at bar graphs, line graphs, pie chart, maps, and a combination. Okay, but the key, once again, is not to get intimidated, but to be able to tackle this systematically. Okay, if we look here, we have an example of a bar graph. And when you look at the bar graph, we are looking at bars that represent certain numbers. Okay. And what you want to look at first is you want to look at the x-axis. The x-axis is the bottom, and then you want to look at the y-axis. The y-axis is the vertical axis that's going up and down. Okay. Within the y-axis, we're going to find that we're going to have our units of measure, and we're going to see what's being measured. Okay. And in the x-axis, how's that being divided? What's going to be key is the title. The title is going to tell you a lot because it should be a descriptive title. It could even have a subtitle as well that gives you a little bit more information. Okay. Now, the way at the bottom in this case, you can see that we have the key where it explains what the colors are. All right. So with this one, we see that it says U.S. population health management market. It's talking about the size by the product from 2023 to 2033. So that's what's being expected. Okay. In our y-axis, we see that it says the market size and it's being recorded in US dollars in billions. Okay. So we can see that that's a money measurement. And then across horizontally, we can see that that has to do with years. Okay. So, of course, it's estimated, is what it's saying, because we're in 2026 at this moment in time. Okay. So, you can see that the purple says services, and then in the blue, we have software. Okay, so what we're seeing is that they can expect an increase year after year in services and in software across time. That's basically what it's saying. Okay, how are we getting these numbers? That's going to be explained a little bit more if you were to dig into how it was put together. Okay, but this is just one example of a bar graph. Okay. Now, if we look at a line graph, this is an example of a line graph. Okay, with the line graph, oop, went a little too fast. Okay, the line graph. Well, all right. Sorry about that. The line graph is going to tell us some metrics, and it can tell us a line that's connected and it's continuous. In this case, we're looking at fiscal year. If we look at the title, it can be at the bottom of the figure where it says proportions of NIH, which is the National Institute of Health, funded projects that included the terms population or public in their titles in fiscal year 2004 to 2014. What is this telling us? Well, if we look at the y-axis, we see that it's saying the percent of total funding. So what's the total percent of the entire funding? And it's across time. And we can see that the percent has been going down and down year after year, except in 2009. Okay. So you can see that here we're seeing a graph that is looking at things across time. Okay. Okay. A pie chart's a little different. It's going to tell us a little bit more of information within a group of people. Okay. In this case, we're looking at the title. It says Alzheimer's disease, a woman's health issue, a woman's health cure. That's what the title is. And it's from the National Institute of Health, as you can see there on the lower left corner. So it says lessons from the 67%. And this is part of a video or something that was being shown, but you can see that your key here is really creative. You can see that the one in red are the female, the one in blue are the males, and you can see because of the dress as well. And it says 60% are women, 33% are men. In this case, it's telling us a snapshot of Alzheimer's disease. Now, that's all we get. We don't get any more information. We don't know years. We don't know where is the sample size from. Is it worldwide? Is it only in the United States? Anything like that would have to be described. But these are questions that you would want to ask. What is being told? What is not being told? Okay? You can't infer anything that is not being told to you. Okay. Then you have maps. There's a way that you can have maps of countries, of cities, of in this case it's our country, the United States. We can see that it says uninsured rate by state in the year 2011. So this is what it was like in 2011. All right. And we can see that we also have Alaska up there represented. And there's a key at the bottom right-hand corner, and it's giving us the percentage without health insurance. The darker the blue, the higher the percentage. The lower, it means less of a percentage of coverage. So here we can see either by numbers or colors, um, you can see a representation of what's trying to be conveyed. And here what is being shown to us is that there in 2011, there were more uninsured, more in the darker blue states as opposed to the lighter blue. Okay. This is just another example of how you can report your data and how would you interpret that. Okay. And lastly, here we have one that's a combination. You could see graphs that are a combination of different graphs of different numbers um, um, so we can make a point. Okay. In this case, it says Medicaid cuts could add millions to US uninsured. Okay. And this is basically an extrapolation. What's an extrapolation? You take some data and you try to infer what the number would be in the future. In this case, they're trying to do that with 2034. Okay. That's what extrapolation is. You're inferring, you're calculating what it could be based on the trends that you see now. And what you see is that they've reported their numbers and then they're reporting that there's going to be an increase. Okay. Where the two graphs come in, if you notice, is that there's another y-axis on the right side. So you see the combination of the bar graph along with the line graph, and it's making a point that it has gone down and then it's expected to go up again. Okay. You also want to see that if a graph has a lot of a, a bit of a description at the bottom in a caption of some sort, it's going to have more information there as well. Okay. All right. So what are the 5 items needed to interpret a graphical data? We covered these already, but let's go a little bit more into them. The title of the graph is going to tell you a lot. The x-axis, which is the bottom axis that's going across, is going to tell you what's being represented. So read the title there. The y-axis, which is the vertical, what data? Okay. The legend is going to tell you a lot, or the small box of representation, and the units of measure. That's usually on the y-axis. You have to understand what's being measured and how it's being measured. If you don't have any one of these, it could be incomplete. And even having all of these, you could have an incomplete view unless you ask questions. And the purpose is to be a critical thinker, to really understand what you're looking at and not just take it at face value. Remember what is being told to you and what is not being told to you. All right. All right. Well, you have a wonderful day now.